Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fourth question from the mid-year examination which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 8 videos since this chemistry paper had 8 questions in total. That means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay. Question 4. We are told that the flow diagram below shows 3 organic reactions, namely reaction 1, 2, and 3. Various organic and inorganic products are formed as a result of these reactions. Okay, reaction 1, guys, is a reaction this is just a hydrolysis reaction. Guys, we are moving from a haloalkane into an alcohol. Are you together? And the reaction conditions of our hydrolysis reaction, guys. Yes, they've given us our base, but please note that, guys, our base is supposed to be dilute. It's just a dilute strong base, and we must also have mild heat for us to perform this hydrolysis properly. And then reaction 2 is an elimination reaction. Once, guys, you see heat as well as sulfuric acid, this is an elimination reaction. This guy over here will be eliminated to form a double bond over there. So this is just an elimination reaction, and the type of elimination reaction, it's dehydration, because you are removing water in compound B. And then reaction 3, now we have our alkene, we are adding hydrogen, so this is just addition reaction. Addition reaction, the type of addition reaction is just hydrogenation. Are you together? And the catalyst needed for hydrogenation, it can be platinum, or it can be lead, or nickel. Are you together? But platinum is used mostly, so go with platinum as well. And then for compound C, guys, we have our hydrohalogenation. Hydrohalogenation, it's an addition reaction. This one, let's call it reaction 4. It's an addition reaction, guys. So it's going to be hydrohalogenation. Okay, now let's answer these questions, guys, because I've just scanned the flow diagram there. I will deeply explain the flow diagram in bits and pieces, and I'll be led by the question. Use the flow diagram above to answer the following questions. First question: define the term saturated compound. Saturated compounds, guys, are organic compounds that have single bonds between adjacent carbons. Organic compounds that have single bonds between adjacent carbons. 2-bromopropane undergoes hydrolysis. Okay, it undergoes hydrolysis. Name the type of reaction represented by reaction 1. So let's focus on reaction 1, guys. We have 2-bromopentane rather. I have 1, 2, 3, 4, 5, and then in carbon number 2, I have my bromo over there, and then I have my hydrogens. Okay, for this to undergo hydrolysis, guys, I need to have my dilute strong base, potassium hydroxide. It must be dilute. Are you together? As well as mild heat. And then this will simply form a hydrolysis. I'll simply substitute the OH with the Br. I'll end up having 1, 2, 3, 4, 5. I'll end up having an OH over there, and since the OH will substitute with the Br, the inorganic product which is formed will be just potassium bromide. And then all I have to do is to write the hydrogens over there. By just drawing this equation, guys, using structural formulas, I believe that you can already answer the questions. So name the type of reaction represented in reaction 1. They did tell us that it's hydrolysis, so we don't want to repeat that. Let's just say it's substitution. Substitution reaction. Are you together? And the type of substitution reaction is hydrolysis. Okay, and then we must name the inorganic product A. The inorganic product that we have, guys, is potassium bromide. Potassium bromide, né? And then we must give one reaction condition. We must have a dilute strong base, number 1. Secondly, we must have mild heat, né? The strong base, guys, is not only potassium hydroxide, né? It can be potassium hydroxide, it can be sodium hydroxide, it can also be lithium hydroxide as well. Okay, and then now we are supposed to consider compound B. Compound B, guys, is our alcohol over there. Compound B is our alcohol. They want us to write down the IUPAC name of compound B. The IUPAC name, I must start numbering my carbons from the terminal which is closer to the functional group. So this will be carbon number 1, 2, 3, 4, and 5. So the parent chain is 5 carbons, so the prefix will simply be pent, né? So whenever I name this thing, I'll simply say this is pentane 2-ol, because the functional group is in carbon number 2, né? It's just pentane 2-ol. Name the type of reaction represented by reaction 2. Once I see, guys, sulfuric acid, once I see a sulfuric acid present in a reaction that has alcohol, I must know that this is an elimination reaction. And what they did not mention there is that this sulfuric acid has to be concentrated. Are you together? So it's an elimination reaction, and the type of elimination reaction, guys, is dehydration, because I'll eliminate water over there. The type of elimination reaction is just dehydration, eh? Elimination, and its type is just dehydration. Okay, and then now I'm told that I'm asked rather to write down the structural formula, of the major products of compound C. Okay, what actually happens here, guys, is that I have my alcohol over there, as well as my hydrogens. Okay, let me just write the H's as well. So, guys, since I'm eliminating, I'm going to apply Zaitsev's elimination rule. I have H2SO4, which is concentrated in the presence of heat. Are you together? So all I have to do, guys, is to apply the Zaitsev's elimination rule. It simply says I must just eliminate the hydrogen from the carbon with the least number of hydrogen atoms. So since I'm supposed to eliminate this guy, I must take the hydrogen either from this carbon or that carbon for me to form a major product. Are you together? But I can only take either one of these carbon from either one of these hydrogen from the carbon that has the least number of hydrogen atoms. Carbon number 2, this carbon over here, carbon number 3, has the least number of carbon has the least number of hydrogens rather, compared to the carbon which is at the terminal carbon. It has 3 hydrogens. So I'll simply eliminate those 2 over here. These will be eliminated just to form a double bond. they'll be eliminated just to form a double bond over here. Right, together. And then my major products will simply be C, 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 and C. I still have my hydrogens over there. Please note that, guys, your carbons should always be surrounded by 4 bonds. Not more, not less, but always 4. Né? Okay, so these guys will simply be my major products, and the inorganic products, or the minor products, not minor, but the inorganic products will simply be H2O because it has been eliminated over there. Né? So this is the structural formula of our major product over there. Can I fit it here? No, I can't. So this guys is just a structural formula of our major products. Are you together? Our major product is just an alkene, and the IUPAC name of this major product, it's pent-2-ene. Let me go and draw the structure of compound C. That's pent-2-ene. I simply have my hydrogens over there. That's how, guys, you should have drawn your this is the structural formula of compound C, actually, the major product of compound C. Okay, now let's answer the other questions. They want us to write down the chemical formula of the inorganic product formed in reaction 2. You said you have formed water. Okay, and then for reaction 3, they want us to name the type of addition reaction. Reaction 3, guys, you are moving from this unsaturated hydrocarbon into a saturated hydrocarbon, which is pentane. For us to do that, we must add hydrogen. Né? The type of addition reaction is just hydrogenation, and the catalyst needed, it's platinum or lead or nickel. Né? So let's go and answer those 2 questions over there. The type of addition reaction is hydrogenation because we are adding hydrogen. And then the chemical formula of the catalyst, you can use platinum, you can use lead, you can use nickel. Just pick one of the 3 catalysts, guys. Né? You'll get your correct answer. Okay, now let's move to question 5.4, rather 4.5 rather. Esterification is one of the most important reactions in both organic synthesis and the chemical industry. When making an ester, 60 grams of propane-1-ol reacts with an excess ethanoic acid, which produces 90.78 grams of an ester and water. Excuse me. Write down the structural formula of guys, for the ester produced. Okay. Before we answer this question, guys, let's just write down this equation by using structural formulas. I simply have propane, not propane rather, but propane-1-ol. Né? That's propane-1-ol, and I'm reacting it with an excess ethanoic acid. An excess amount of ethanoic acid in the presence of concentrated sulfuric acid, guys. In the presence of concentrated sulfuric acid. And what will happen over here, guys, I'll form an ester by eliminating water. The alcohol will just donate an H+, but the acid will donate an OH. And then I'll simply have an ester which looks like this: 1, 2, 3 with an O, and then a C with a double bond, and a C again. So this will be the structural formula of my ester, guys. Né? The first part over here is contributed by the alcohol, and the second part is just the contribution of an ester. We obviously have our inorganic products as well, which is just water. That's H2O in structural formulas. Okay, so to answer the first question, guys, to write down the structural formula for the ester produced, this is the structural formula, guys. For our ester, the IUPAC name of our ester, since the alcohol part is this one, it had 3 carbons, so we'll simply say this is propyl ethanoate. Propyl ethanoate. Okay, the chemical name of the catalyst that was used is just sulfuric acid. Are you together? Sulfuric acid. And please note that, guys, our sulfuric acid has to be concentrated. Okay, and then now they want us to calculate the percentage purity of our propane 1-ol. Okay, so this alcohol of ours, guys, was not fully pure. Are you together? But only the pure part of it will react with the carboxylic acid to form this ester. Are you together? So we are given the mass of our ester. Let me find the molar mass of the ester first, because I will need it. Né? The molar mass of our ester, it's C5, H10, and O2. So this is basically 5 times a carbon. I know the molar mass of carbon is 12 plus 10 times hydrogen. Hydrogen is a molar mass of 1 plus 2 times oxygen. Oxygen is a molar mass of 16. So the relative atomic mass number for our ester is just 5 times 12 plus 10 times 1 plus 2 times 16. So this is just 102 grams per mole. I'm just finding the molar mass, guys, because I will definitely need to find the number of moles for both my alcohol and ester. So the molar mass for my alcohol, which is C3H8 and then OH, is basically 3 times the number of carbons. Carbon is 12, right? And then for hydrogens, I have 9 hydrogens. It's 8 plus 1. That's 9 hydrogens. Hydrogen has a molar mass of 1. And then oxygen is just 1. So I'll just say plus 16. So this guy over here will simply give me 3 times 12 plus 9 times 1 plus 16. So this will just give me 61 grams per mole. I'm just calculating, guys, these molar masses because I will need them to find the number of moles. Né? Okay, since I'm given the mass of my ester that was formed, I can simply find the number of moles of my ester. So the number of moles of my ester, that's C5H10O2, is basically mass divided by the relative atomic mass number. That's 90.78 divided by 102 grams per mole. So 90.78 divided by 102. So this will simply give me 0.89 moles. Are you together, guys? It's just 0.89 moles. Né? Please check here, guys. Since the ratio is just 1 is to 1, this simply means I will need 1 mole of for me to produce a certain amount of an ester, I must use the same amount of an alcohol. Are you together? So therefore, the number of my alcohol which were used to form this ester, the number of moles is equal to the number of moles of the ester that was formed, because the ratio just simply says 1 is to 1. Né? So I simply used 0.89 moles. The alcohol that was used was basically 0.89 moles. Né? So I can simply find the mass of my pure alcohol, because the pure part of the alcohol, guys, is the one that will react with our carboxylic acid to form this ester of ours. So I know that number of moles is equal to mass divided by the molar mass. That's 0.89 is equal to mass. For molar mass, we got 61. So therefore, the mass of our alcohol, which reacted with the ethanoic acid is just 0.89 multiplied by 61. This will just give me 54.29 grams. 54.29 grams, right? But remember that, guys, I was given 60 grams of alcohol, of my alcohol, but I can see that only 54.29 grams reacted with the acid. So this means the other part was not pure, right? So for me to find the percentage purity, I just need to take the mass of my alcohol that was pure divided by the mass of my total alcohol multiplied by 100. The pure mass is just 54.29 and the total mass of our alcohol is 60 grams. Multiply this by 100, you will simply get an answer of 90.48%. So our alcohol, guys, was not 100% pure, but it was 90.48% pure. The other part of it was just impurities of alcohol. So that's how, guys, you should have tackled that question over there. So please do stay tuned and wait for more videos. Thank you.